So in last class, we said that we will be discussing something on AT, VT and ST diagrams. AT is acceleration versus time diagram, VT is velocity versus time diagram, and ST is position versus time diagram. Now, can you read problem number 31 for me?
Yes, sir. Draw 81 ST diagram. Compute position, velocity, acceleration at time is equal to 15 seconds, and compute total distance traveled from 5 to 15 seconds.
Yeah, that is one thing. Another one is S at t equal to 0. That is position at t equal to 0 is already given as minus 100 meter. So the particle did not start from the origin. It started from minus 100 meter. That means it started from 100 meter on the negative side of x-axis from origin. Are you with me?
Yes, sir.
So imagine that this is our positive x-axis and this is the origin. Then at time t equal to 0, the particle was occupying position somewhere here, where this distance is 100. Are you with me?
Yes, sir.
So this is the position at s is equal to 0. Happy?
Yes, sir.
Okay. And now we have to draw, we are going to handle part A first. So we have to draw AT diagram and ST diagram. So you have been given velocity versus time diagram. उसके जैसा ही position versus time and acceleration versus time diagram आपको draw करना है. Are you with me?
Yes, sir.
Okay. So for that we must first define velocity time as a mathematical function. So velocity is the function of time in all the segments. देखो, from 0 to 5 the velocity is linear. Then from 5 seconds to 15 seconds it is parabolic, and from 15 seconds to 40 seconds also it is parabolic but with different equation. Are you with me?
Yes, sir.
When I say linear, that means velocity is first power function of time. When I say it is parabolic function, that means velocity is the second power function of time. Are you with me?
Yes, sir.
Okay. Now let us go ahead. So let us talk about equation of velocity from 0 to 5 seconds. So equation of velocity from 0 to 5 seconds is a linear variation. So it is line. So what is the typical equation of line? Y is equal to mx plus c. Do you agree with me?
Yes.
And on y we are plotting velocity now. So velocity, and on x it is t. So the equation will be v equal to a1 t plus b1, where a1 and b1 are constants. Do you agree with me?
Yes, sir.
Okay. Now at t equal to 0, we have velocity equal to 0. So therefore, if I substitute this in v equation for v, I get 0 equal to a1 into 0 plus b1. So I get b1 equal to 0. Are you getting this?
Yes, sir.
Okay. Now, so at t equal to 5 seconds, velocity is 10 meter per second. This is the second information that we have. So if I substitute that in this original equation, I get 10 is equal to a1 into 5 plus b1, which is already evaluated as 0. So therefore, I get a1 equal to 2. So v equal to 2t is the equation of velocity in 0 to 5 seconds. Do you agree with me?
Yes, sir.
Now, just have a look at unit of velocity. It is meter per second. And just have a look at unit of time. So unit of time is second. So on right hand side, if I want this to give you velocity in meter per second, what must be the unit of this constant? Unit of this constant must be meter
Meter.
per second square. Do you agree with me?
Yes, sir.
So this is also a unit of acceleration. Are you with me?
Yes, sir.
So just keep in mind that this is also a unit of acceleration. So I have got the equation of velocity in closed interval t equal to 0 to 5. Now let us look at equation for velocity in the interval 5 to 15 seconds. Are you with me?
Yes, sir.
And the equation is given as parabolic. So what is the general form of parabola? So we have the equation as v equal to, that is y equal to a1 ax square plus bx plus c. This is the equation, general equation of parabola. So यहाँ पे x पे क्या है, टाइम है, and y पे क्या है, वेलोसिटी है. So v is equal to a2t square plus b2t plus c2, where a2, b2 and c2 are constants to be determined. Are you with me?
Yes, sir.
So I have taken the general equation of parabola, and now I am going to apply conditions. How many conditions would I require to evaluate three constant? I will require three conditions. Do you agree with me?
Yes, sir.
What is the first condition? First condition is easy. At time t equal to 5 seconds, velocity is equal to 10 seconds, 10 meter per second. So therefore, I substitute that 10 must be equal to, if I substitute t equal to 5 here, it becomes 25. So 25 A2. If I substitute t equal to 5 here, it becomes 5B2 plus C2. So 25 A2 plus 5B2 plus C2 must be equal to 10 is the first condition that I have. Do you agree with me?
Yes, sir.
What is the second condition? For second condition, look at time t equal to 15 seconds. What is the value of velocity there? Minus 20 meter per second. So the second condition that I am going to write is minus 20 is equal to, when I substitute t equal to 15 seconds here, this becomes 225 A2. When I substitute t equal to 15 seconds here, it becomes 15 B2 plus C2. Do you agree with me?
Yes, sir.
So this is the second equation. Now tell me, look at this diagram and tell me what will be the third equation. How should I get the third condition?
So 40, sir. At 40.
No, at 40 there is different parabola. The equation of parabola which is marked in blue line is not valid. The equation of parabola in red color is different. Do you agree with me?
Yes, sir. So will it be minus 20 then, sir?
Pardon?
So will it be minus 20 then, sir?
What is minus 20? That condition we have already used. At t
Yes, sir.
equal to 15 seconds, we have velocity equal to minus 20 meter per second. That condition is used. As at time t equal to 5 seconds, we have velocity equal to 10 meter per second. This condition is used. How do I get the third condition?
So can we take the point about the origin, sir, where it's cutting the time axis, x-axis?
No, you cannot, because from time 0 to 5 seconds, it is linear variation. So this parabola doesn't extend there.
Okay, sir.
Do you agree with me? If
Yes,
I
sir.
continue this parabola, there is no guarantee that it will pass through origin. This line is passing through origin. Do you agree with me?
Sir, I meant the intersection of the parabola with the x-axis, sir. Closer to 15, sir.
Uh, Closer to 15.
15, sir. Yes,
But
sir. This
do you know
intercept.
the time? Do you know the time at which that occurs?
No, sir.
No. So how can we use that condition? Data incomplete, data information नहीं है ना हमारे पास. Are you
Yes,
with
sir.
me? So I want to bring your attention to a visual graphics here around 5 seconds. जरा देखो, ये जो line black color में दिखाया है, that line also happens to be the tangent to this parabola here. Do you agree with me?
Yes, sir.
So how do you mathematically represent that? That this black line has to be tangent to the parabola drawn in blue color at 5 seconds. इस condition को हम mathematically कैसे replace करेंगे? So you have to understand, if I have, so we will take a digress. If I have a function y as a function of x, so what is the interpretation of dy by dx at x equal to x1? So at x equal to x1, if I draw tangent to this curve, are you with me?
Yes, sir.
That tangent has a slope which is equal to dy by dx at x1. Do you
Yes, sir.
agree with me?
Yes, sir.
So what is dy by dx? Y is a function of x. Then dy by dx at x equal to x1 is nothing but slope of tangent drawn to y at x1. Do you agree with me?
Yes, sir.
This is the graphical representation of differentiation. Dy by dx at x equal to x1 is slope of tangent drawn to y at x1. So what is dy by dx at x equal to x2? So at x equal to x2, I have to draw tangent to this y again, and then slope of that tangent will be dy by dx at x equal to x2. Do you agree with me?
Yes, sir.
Okay. Now that condition we are going to use here. So if I calculate dy by dx, so here it will be dv by dt. Do you agree with me?
Yes, sir.
Dy by dx is like dv by dt here because y is replaced by v, x is replaced by t. So therefore dv by dt, where? At 5 seconds, at time t equal to 5 seconds. This should give me what? This should give me slope of tangent drawn to this parabola at 5 seconds. Do you agree with me?
Yes, sir.
But what is that slope? What is slope of that tangent? Slope of tangent is nothing but slope of this black line. Do you agree with me?
Yes, sir.
Because we say this black line itself, we can see that it is tangential to the parabola at time t equal to 5 seconds. Happy?
Yes, sir.
अब तो ये है हमारा तीसरा कंडीशन. So how do I write third condition? देखो मैंने कैसे लिखा है. Third condition is written as at time t equal to 5 seconds. At t equal to 5 seconds, dv by dt, that is slope of tangent drawn to the parabola, is equal to slope of this black line. What is the slope of this black line? Look at its equation. V is equal to 2t. So what is the slope? Slope is 2. Do you agree with me?
Yes, sir.
So the third condition we got, at t equal to 5 seconds, dv by dt is ought to be 2 seconds. In order to have this black line tangential to this parabola at time t equal to 5 seconds. Are you with me?
Yes, sir.
Okay. Now, can you find out dv by dt? Answer is yes. This is the expression for v. So what will be dv by dt? It will be 2a2t plus b2. Do you agree with me?
Yes, sir.
dv by dt will be equal to 2a2t plus b2. Are you with me?
Yes, sir.
Now, I have to evaluate that dv by dt where at time t equal to 5 seconds. So क्या करना पड़ेगा? I will have to substitute t equal to 5 seconds here. So it becomes 10 times a2 plus b2. Do you agree with me?
Yes, sir.
So 10 times a2 plus b2 plus 0 times c2 must be equal to 2 is the third equation. Are you with me?
Yes, sir.
So now we can solve these three equations and we can get the value of A2, B2 and C2, and therefore we can substitute that value of A2, B2, C2 into this parent equation and we can write down the equation of velocity in the time belonging to closed interval 5 to 15 seconds. Are you with me?
Yes, sir.
So V is equal to minus 0.5 t square plus 7t minus 12.5. Happy?
Yes, sir.
तो वेलोसिटी का इक्वेशन हमें कहाँ पे मिल गया? We got the equation of velocity from range 5 to 15 seconds. Happy?
Yes, sir.
Now we need to find out equation of velocity from 15 to 40 seconds. What kind of equation it is? It is also parabolic because it is given in the problem that velocity varies as a parabolic function of time from time t equal to 15 seconds to 40 seconds. So how does the equation look like? It will be a3t square plus b3t plus c3. These constants will be different than the constants here because this is different parabola, this is another parabola. Are you with me?
Yes, sir.
Okay. And we need to now come up with three conditions in order to get a3, b3, c3. Happy?
Yes, sir.
So what are those three conditions? Two conditions are easy. At time t equal to 15 seconds, you have the value of velocity as minus 20. So at t equal to 15 seconds, we equal to minus 20. So minus 20 is equal to a3 into 15 square, which is 225. Are you with me? 1 minute.
Yes, sir.
Hello?
Yes, sir.
Yes. So 225 into a3 plus b3 into t, that is 15 into b3 plus c3. Do you agree with me?
Yes, sir.
This is equation number 4. Now, what is the next condition? At time t equal to 40 seconds, velocity is 0. Happy?
Yes, sir.
So I'm using that condition and then I can write 0 is equal to 40 square into A3, that is 1600 into A3 plus 40 B3 plus C3. So I have got fourth and fifth equation. How do I obtain one more equation? Tell me.
Using the same tangential form that we found previously.
So can you spell that condition? अब जरा
So
यहाँ पे देखो, if I draw tangent to the earlier parabola here, it looks something like this. Do you agree with me?
yes, sir.
And if I draw the tangent to this parabola here, it looks something like this. Are you
Yes,
with
sir.
me? So are these two tangents having same slope? No. One
No, sir.
tangent is having positive slope, another is having negative slope. This tangent marked in black color is having negative slope. Tangent marked in blue color is having positive slope. That means if I were to draw tangents to the parabolas at 15 seconds, the left hand side parabola is going to have different value of slope of tangent. Right hand side parabola is going to have different value of slope of tangent. So I cannot really use the condition which I used earlier. Are you with me?
Yes, sir.
Earlier कैसे हुआ था? This line itself was the tangent to the parabola at 5 seconds. Are you with me?
Yes, sir.
वो तो condition यहाँ पे है नहीं. So अब क्या करें? What will be the third condition? Can you tell me?
Sir, will we be able to use normal instead of tangent, sir?
Normal instead of tangent. But then again, if you don't know the equation of tangent, you will not be knowing the equation of. If you know nothing about the tangent, you will know nothing about the normal as well. Are you with me?
Yes, sir.
By that what I mean is, let us say you are considering a Cartesian coordinate system. If you know how is x oriented, then only you can know how y is oriented. It is at 90 degrees to x. Do you agree with me?
Yes, sir.
तो अब हमें अगर टेंजेंट का ही इंफॉर्मेशन नहीं है तो नॉर्मल का इंफॉर्मेशन होने का सवाल ही नहीं. Are you
Yes,
with me?
sir. Yes, sir.
Okay. So what will be the third condition?
So can we take it similar to what we took the last time, as in, sir, A3 into T plus B3, sir, by differentiating this? Because, sir, the value should be same regardless of whether the slope is positive or negative, right, sir? The acceleration
No,
remains same, sir.
no. Value of velocity is same. I agree. But the slope of tangent drawn is clearly you can see that it is going to have different values. Do you agree with me? Are you with me?
Yes, sir.
What you are saying that acceleration, how can it have two different values at same time? Because dv by dt is acceleration. That
Yes,
point
sir.
we are going to come to it when we draw the acceleration time diagram. We will discuss that. Are you with me? But visually, as you can see, this parabola is going to have different slope of tangent at 15 seconds than the parabola marked in red. Do you agree with me?
Yes, sir.
Now, what can you say something about tangent drawn to this parabola drawn in red color at 40 seconds?
Yes, sir. That'll have a single value, sir.
Uh, and, and that will be horizontal. Do you agree with me?
Yes, sir.
जैसे दिखाना है उस तरीके से that tangent is horizontal. Do you agree with me?
Yes, sir.
And what is the slope of tangent if it is horizontal? 0.
Yes, sir.
So can I write this condition dv by dt at time t equal to 40 seconds, which is slope of tangent drawn to this red color parabola at time t equal to 40 seconds. This has to be equal to 0
Yes, sir.
because the tangent drawn to this red color parabola at 40 seconds is horizontal. Horizontal line has 0 slope. Are you with me?
Yes, sir.
That is the third condition that we are going to exhaust. What is the third condition? At time t equal to 40 seconds, dv by dt is 0 because the tangent drawn to the parabola at time t equal to 40 seconds is horizontal. Happy?
Yes, sir.
So, the required information will be hidden in the problem in one or the other way. You need to just mathematically identify it. Are you with me? The
Yes.
realization of what is being said is important. Then you can find out all the equations. Happy?
Yes, sir.
Okay, so let us try to now state this third condition. So what is how do I differentiate this V? If I differentiate this V, I get it as 2a3 into t plus b3. Do you agree with me?
Yes, sir.
At time t equal to 40 seconds, that means if I substitute the value of t as 40 seconds here, I should get 40 into 2 into a3 plus b3 must be equal to 0. In other words, 80 a3 plus b3 plus 0 c3 must be equal to 0. We have now three equations in three unknowns. We can solve for them. We get A3 as minus 4 by 125, B3 as 64 by 25, and C3 as minus 256 by 5. Happy?
Yes, sir.
This equation of velocity is valid in closed interval, closed time interval 15 and 14. When I say closed time interval, I show this square bracket. What does it mean is, this equation is valid even at t equal to 15 seconds and 40 seconds. End values included. Therefore, I call it as closed interval. Are you with me?
Yes, sir.
Okay. Now,
So,
so we have got, yeah, go ahead.
so if we substitute the value of at t is equal to 15 in equation number, the one we've just found out, and the previous one for the parabola that's in the positive axis, sir, we should get the same value, right, sir?
Yes, you will get the same value. You can try that. So you can substitute t equal to 15 seconds here and t equal to 15 seconds here. Velocity you must get same at time t equal to 15 seconds. And that must be equal to minus 20. You can try that. I will give you some time. So I'm giving you another 1 minute. You try and let me know. Till that time, I will recording. So we have cross-verified that in both these parabolic equations, if I substitute t equal to 15 seconds, which is boundary of these two parabola, at that 15 seconds, we get same value of velocity. However, acceleration value will not be same. We will look at that in a while. Are you with me?
Yes, sir.
Okay. So we have got the equations of velocity in all the three zones. What do we do next? We have to draw AT and ST diagram. Do you agree with me?
Yes, sir.
We are naturally going to use these velocity equations in order to draw these AT and ST diagrams. But before we do that, what I am going to do is I am going to take a digress and I am going to explain you about the graphical representation of relationship between position, velocity, and acceleration. Are you with me?
Yes, sir.
So for that, I have considered an thought experiment where y is a function of x and it seems something like this. So I already told you what is the interpretation of dy by dx at x equal to x1. Have I?
Yes, sir.
Okay. So if I take dy by dx at x equal to x star, what is its interpretation? It is slope of tangent drawn to y at x star. Happy?
Yes, sir.
Okay. Now let us try to interpret what do we mean by integration of this y in the range x1 to x2. Y is a function of x. So I can integrate it with reference to dx. So integration y dx from x1 to x2. What does it give? Tell me. Graphically. Does it give me this shaded area?
Yes, sir.
So we have already learned that in our 12th standard or maybe 11th standard integration lessons, that integration of a function y as a function of x from x1 to x2 gives me area under yx curve from x1 to x2. Do you agree with me?
Yes, sir.
And that area, I will denote it as the shaded area here. So therefore, I can also write this as area of shaded portion. Are you with me?
Yes, sir.
Now, let us extend this graphical interpretations of differentiation and integration. Differentiation gives you slope of tangent. Integration gives you subscribed area. Are you with me?
Yes, sir.
Okay. Now, so let us try to let us try to graphically represent relationship between S, V, and A. So can you tell me the relationship between velocity and S? Velocity is
Velocity is equal
ds
to
by
ds by
dt.
dt, sir.
Do you agree with me?
Yes, sir.
So what is ds by dt? It is nothing but slope of tangent drawn, slope of tangent drawn, drawn to displacement or position versus time curve. Do you agree with me?
Yes, sir.
At t, that t can be anything. If I ask you to calculate velocity at time t equal to t1, what should I do? I should calculate ds by dt at time t equal to t1. Are you with me?
Yes, sir.
Or in other words, what should I do graphically? At time t equal to t1, I should draw tangent to st diagram and I should measure its inclination with reference to horizontal and I should take tan of that. Are you with me?
Yes, sir.
Possibly it will be clear if I draw it here. So for example, let us say this is s of t. This is s as a function of time, and I were to calculate velocity at time t1. So to calculate velocity at time t1, मुझे क्या करना पड़ेगा? At time t1, I will have to draw tangent to this st diagram. Do you agree with me?
Yes, sir.
इस टेंजेंट ने टाइम एक्सिस के साथ जो एंगल किया है थीटा, the slope of that tangent is tan theta. Do you agree with me?
Yes, sir.
So v at t1 will be equal to tan theta graphically. Do you agree with me?
Yes, sir.
I hope I am as clear as possible. अगर इसमें किसी को कुछ डाउट है तो पूछो. I am dwelling on your 11th and 12th standard knowledge of integration. Are you with me?
Yes, sir.
Okay. So now let me try to write down what is acceleration. Acceleration is dv by dt. Do you agree with me?
Yes, sir.
So is it slope of tangent drawn to vt diagram or vt curve? Do you agree with me?
Yes, sir.
At time t. So इसी तर्ज पे मैं बोलूंगा, if I have velocity versus time diagram of this nature, this is velocity and this is time, and I were to find out acceleration at time t equal to t1. Are you with me?
Yes, sir.
तो मुझे क्या करना पड़ेगा? At time t1 I will have to draw
Tangent, sir.
slope. I will have to draw tangent. Are you with me?
Yes, sir.
This vt diagram, and whatever angle it makes with t axis, tan of that is going to be this. Do you agree with me?
Yes, sir.
Okay. So I got what is dv by dt graphically, and that is acceleration. I got what is ds by dt graphically, and that is velocity. Happy?
Yes, sir.
Okay. Now, so this was the forward interpretation. So from velocity, I wanted to calculate from position, I wanted to calculate velocity. From velocity, I wanted to calculate acceleration. The process was of differentiation, and differentiation was interpreted as a slope of tangent. Happy?
Yes, sir.
Okay, now let us do the reverse operation. I have acceleration versus time diagram, and I want to get velocity. What should I do? So let us now talk about the reverse operation. Are you with me?
Yes, sir.
I have acceleration versus time diagram. It looks something like this. This is acceleration. This is time. Are you with me?
Yes.
Before we go ahead, I want to clear one thing. You may see the position versus time diagram as non-linear. Are you with me? But
Yes, sir.
the motion is occurring along a line. You have to understand that. Are you with me?
Yes, sir.
So motion तो एक ही line के along हो रहा है, because we are still now into rectilinear motion. We have not talked about curvilinear motions. Are you with me?
Yes, sir.
तो मोशन तो चल रहा है लाइन के अलॉन्ग, लेकिन उसके पोजीशन वर्सेस टाइम डायग्राम एंड वेलोसिटी वर्सेस टाइम डायग्राम एंड एक्सेलरेशन वर्सेस टाइम डायग्राम, ये सारे नॉन लीनियर हो सकते हैं. आर यू विथ मी?
Yes, sir.
Okay, so I hope you have understood that point. It is very subtle, but you have to understand that. Now let us talk in reverse sense. We have acceleration versus time diagram, and I want to calculate velocity versus, I want to draw velocity versus time diagram. What should I do?
So
So
integrate.
again, I'm going to use the relationship A is equal to dv by dt. But now I will have to integrate, because I know acceleration in dt will be equal to dv. Do you agree with me?
Yes, sir.
And I will have to integrate both the sides. अच्छा, कैसे integrate करूं? So I will have to अगर मैंने सिर्फ indefinite integral ले लिया तो constant of integration आएगा. Do you agree with me?
Yes, sir.
And that constant of integration is pain. तो वो नहीं चाहिए. So what do? We integrate it in definite time intervals. Let us say time t1 to t2. Are you with me?
Yes, sir.
So I'm going to integrate this A in time interval T1 to T2. So I will write down the interval T1 to T2 A dt is equal to integration velocity at time T1 to velocity at time T2. Do you agree with me?
Yes, sir.
dv. What is integration of dv? Tell me.
So V,
V.
sir.
And if I substitute the limits, isn't it going to be velocity at time t2 minus
Yes,
velocity at
sir.
time t1? Do you agree with me?
Sir.
So is it change in velocity from t1 to t2?
Yes, sir.
Now, what is left hand side? Left hand side का interpretation क्या है? Integration of a of t from t1 to t2 is nothing but the area under the curve. Do you agree with me?
Yes, sir.
So can I write down left hand side as area under acceleration versus time diagram from t1 to t2?
Yes, sir.
Area under acceleration versus time diagram from t1 to t2 gives you change in velocity from t1 to t2. Are you with me?
Yes, sir.
It doesn't give you velocity at time t2. That is misconception. It gives you change in velocity from time t1 to t2. So you must know what was the velocity at time t1 in order to get velocity at time t2 from area under acceleration time diagram. Are you with me?
Yes, sir.
So in other words, इसका ही दूसरा रिप्रेजेंटेशन मैं ऐसे लिख सकता हूँ velocity at time t2 must be equal to velocity at time t1 plus area under acceleration time diagram from t1 to t2. Do you agree with me?
Yes, sir.
When the area under acceleration time diagram will be equal to t2 vt2 only when vt1 is 0. Are you with me?
Yes, sir.
Okay. So are you clear of the graphical interpretation of graphical way of finding out velocity at time t2 by
Yes.
knowing acceleration time diagram? Okay. Operation involved was reverse to differentiation. So therefore geometric parameter involved is also area and not slope. Are you with me?
Yes, sir.
Okay. Now, if I know, now next reverse problem. If I know velocity versus time diagram. Huh. Then how do I get position versus time diagram? So how do I obtain position? So what is the relationship? ds by dt must be equal to velocity. Do you agree with me?
Yes, sir.
This implies, as I know velocity as a function of time, I will take dt on this side. v dt is equal to ds. Agreed?
Yes, sir.
Now integrate. लेकिन इंटीग्रेशन अगर मैंने इंडिफिनिट इंटीग्रल ले लिया तो कांस्टेंट ऑफ इंटीग्रेशन आ जाएगा. So to avoid that, I am going to integrate it in known time interval, say from t1 to t2. Happy?
Yes, sir.
So what do I get? Integration of left hand side from t1 to t2 v dt is equal to integration of right hand side from position at time t1 position at time t2. Do you agree with me?
Yes, sir.
What is the integration of right hand side? S. And therefore, if I substitute the limits, I get it as position at time t2 minus position at time t1. So is it equal to change of position from t1 to t2?
Yes, sir.
And what is left hand side? Left hand side is nothing but this area. So can I write it as area of velocity time diagram from t1 to t2? Are you with me?
Yes, sir.
From t1 to t2. So what is the relationship that we have got? Area of velocity time diagram from t1 to t2 gives you change in position. It does not give you position at time t2. Mind you. Are you with me?
Yes, sir.
So this can also be represented as position at time t2 is equal to position at time t1 plus area under velocity time diagram from t1 to t2. Happy?
Yes, sir.
Okay. So we have now Four graphical interpretations. One है forward process, another है reverse process. What is the forward process? Knowing displacement time diagram, if I were to calculate velocity, I have to go on taking slope of tangents drawn to ST curve. Happy?
Yes, sir.
If from given velocity time diagram, I were to find out acceleration time diagram, I have to go on taking slopes of tangents drawn to VT diagram at various points. Are you with me?
Yes, sir.
That is reverse forward operation. And reverse operation we just now discussed. It talks about the inscribed area under either acceleration time diagram or velocity time diagram from T1 to T2. Are you with me? And that talks about either change in velocity or change in position. Happy?
Yes, sir. Very happy.
Okay. Let us go ahead now and let us solve this problem. Let us first draw acceleration versus time diagram. So we already have velocity versus time diagram. In all these regions, I have expressed velocity as a function of time. Now let us go ahead. Now, when I draw velocity acceleration time diagram from velocity time diagram, am I proceeding in forward fashion or reverse fashion? Follow?
So you'll be proceeding in forward fashion only, sir.
Yes. So which mathematical operator will be involved on velocity time diagram? Differentiation. Agreed?
Yes, sir.
So I have to differentiate this velocity time to get acceleration time diagram. Agreed?
Yes, sir.
What is differentiation of x square with reference to x? Tell me.
So 2x.
हाँ. So x square अगर function है तो उसका differentiation एक power less होता है. Do you agree with me?
Yes, sir.
If x cube is a function, what is the differentiation with reference to x? 3x square.
Yes, sir.
So differentiation is a operator which eats the power. Do you agree with me?
Yes, sir.
Whereas integration is the operator which gives the power. Are you with me?
Yes, sir.
हाँ. तो अब जो कि हम डिफरेंशिएट कर रहे हैं तो पहले तो क्वालिटेटिवली बात करते हैं. From 0 to 5 second, velocity time diagram is linear. That means it is varying as a first power of t. Do you agree with me?
Yes, sir.
So differentiation will land this diagram to what? It will be constant. Do you agree with me?
Yes, sir.
T का first power था वो t का 0th power हुआ. That means t raised to 0 is 1. T raised to 0 is 1. So it is
One.
going to be constant. Do you agree
Yes.
with me? Are you with me?
Yes, sir.
Now, if the velocity acceleration time diagram is parabolic, that means t का second power है. So what will be the nature of velocity time diagram which is obtained by differentiating acceleration time diagram? Linear.
Yes, sir. T to the power 1.
हाँ, so वो linear होने वाला. And even in third zone, 15 to 40 second, it is going to be linear. Do you agree with me?
Yes, sir.
So पहले तो ये चीजें मैंने यहाँ पे observe कर ली. What are the things that I observed? As the velocity time diagram is varying linearly from 0 to 5 seconds, acceleration time diagram will vary as a constant. Then in the remaining zone, as velocity time diagram is varying as parabolic variation of t, acceleration time diagram, however, will vary as linear function of t. Are you with me?
Yes, sir.
Okay. And now, by definition or by graphical representation, what is acceleration? Acceleration at any instant of time is slope of tangent drawn to velocity time diagram at that time. Do you agree with me?
Yes, sir.
तो अब 0 to 5 seconds में देखो, कहीं भी मैं point time consider कर लूं, कहां पे भी मैं tangent draw करूं, that tangent is going to be that black line itself. Do you agree with me?
Yes, sir.
So from 0 to 5 seconds, I observe wherever I draw tangent, the tangent to velocity time diagram is the velocity time diagram itself, and its slope is already known as 2. Do you agree with me?
Yes, sir.
इस लाइन का स्लोप क्या है? डेल्टा v अपॉन डेल्टा t. डेल्टा v is 10, डेल्टा t is 5, 10 by 5, 2. So I know that acceleration time diagram varies as a constant, and that value, constant acceleration, will be 2. Are you with me?
Yes, sir.
So you have to understand from 0 to 5 second, the particle or a body performs uniformly accelerated motion. Do you agree with me?
Yes, sir.
हाँ, तो इसको हम क्या बोलेंगे? यूनिफॉर्मली एक्सेलरेटेड मोशन. uniformly accelerated motion. Now this is not a part of solution, but let me ask you, if the motion is uniformly accelerated, what are the typical formulae that we use, that we have already derived? कौन से formulae है? 11 12 standard physics में derive किया है. S is equal to
ut plus half at square.
हाँ, S is equal to ut plus half at square. V square is equal to u square plus 2as, and then
v is equal to u plus at.
yes, all these formulae are applicable only and only if it is uniformly accelerated motion. That means acceleration is constant. Are you with me?
Yes, sir.
Okay. So this was digress. Now let us go ahead. Now, if I were to draw the velocity time diagram from 5 to 15 seconds, I have made an observation. What is the observation that I have made? That it is going to be linear. Are you with me?
Yes, sir.
Now, draw tangent to this curve, parabola, at 5 seconds, and it is going to have positive slope. Do you agree with me?
Yes, sir.
And that positive slope is 2. So it will start from 2. Happy?
Yes, sir.
Now, as you move along on time axis, what happens to this slope? It becomes lesser and lesser, and finally it becomes 0 here. Do you agree with me?
Yes, sir.
So what should happen to acceleration time diagram? It should go on dropping to 0, and it should become 0 at this point. Do you agree with me?
Yes, sir.
Another observation: wherever you see peak in velocity, acceleration must be 0. Do you agree with me?
Yes, sir.
होना ही चाहिए, क्योंकि तभी तो पीक आएगा वेलोसिटी टाइम डायग्राम में. Then only the tangent here will become horizontal and it will have slope 0. So we know that acceleration is dv by dt. Do you agree with me?
Yes, sir.
So for acceleration to be maximum, dv by dt has to be 0. Do you agree with me?
Yes, sir.
That is the condition for either maxima or minima. So wherever you see maxima of velocity or minima of velocity, at that location acceleration must be 0, provided velocity is a continuous function about that point. Are you with me?
Yes, sir.
Okay, so these are all observations that we are making. So at this point where velocity peaks, I must have acceleration to be 0, and it should continue dropping down, because जरा देखो इसके right hand side में what happens to the slope of tangent? It now becomes negative. Do you agree?
Yes, sir.
Slope of tangent starts becoming negative and its slope goes on increasing. Are you with me?
Yes,
देखो,
sir.
on this, the slope is 0 here, then slope is negative here, और ये line steep होते जाता है. So slope goes on increasing on negative side. Do you agree with me?
Yes, sir.
So acceleration must go on increasing on negative side. Happy?
Yes, sir.
And what is the slope of tangent drawn to this parabola at time t equal to 15 seconds? So अब जरा देखो, what I am going to calculate. I am going to calculate dv by dt at time t equal to 15 seconds. Happy?
Yes, sir.
And this is equal to acceleration at 15 seconds. Do you agree with me?
Yes, sir.
And how much is that? So I will have to look at the expression. 5 to 15 seconds में जो लेफ्ट हैंड साइड का पैराबोला है उसका इक्वेशन ये है. So what is dv by dt? Tell me. -1t plus 7. Do you agree with me?
Yes, sir.
So I will write that. So यहाँ पे लिख देता हूँ -1t plus 7. So -t plus 7. And as I am calculating it at t equal to 15 seconds, I will have to substitute value of t as 15. So -15 plus 7, कितना हुआ? -8. So I will plot acceleration at time t equal to 15 seconds as -8. I already know the acceleration at time t equal to 5 seconds as 2, and I know the variation is linear. Line define करने के लिए कितने पॉइंट चाहिए? सिर्फ 2. Are you with me?
Yes, sir.
So therefore I can draw this line, and that line is fully defined because I have given 2 points on it. By 2-point formula you can write down its equation. Are you with me?
Yes, sir.
Okay, so ये हो गया linear behavior. Now what happens to the acceleration from 15 to 40 seconds? It is also linear. Do you agree with me?
Yes, sir.
But when I draw tangent to this parabola, which is marked in red color, at 15 seconds, what kind of slope is it going to have? Positive or
Positive.
negative? Positive slope. Whereas if I were to draw tangent to this parabola at 15 seconds, it was having negative slope. So here the acceleration jumps at 15 seconds. Are you with me?
Yes, sir.
एक्सेलरेशन ने जंप किया है, कहां से कहा, निगेटिव से पॉजिटिव तक, लेकिन कितना स्लोप है, तो कितना एक्सेलरेशन है, वो कैलकुलेट करने के लिए आई विल हैव टू कैलकुलेट dv by dt. आर यू विद मी?
Yes, sir.
dv by dt at time t equal to 15 seconds itself, but looking at the equation of right hand side parabola. Are you with me?
Yes, sir.
What is the equation of right hand side parabola? Tell me. This one. So if I were to take differentiation of this, what do I get? Minus 8 upon 125t plus 64 by 25. Do you agree with me?
Yes, sir.
So that I am going to write minus 8 upon 125t plus 64 by 25. Can you evaluate this at t equal to 15 seconds? Tell me how much it is. Are you with me?
Yes, sir.
Yeah, please do that.
So 1.6.
1.6, and it is positive value. So at
Yes.
time t equal to 15 seconds itself, the body is exhibiting acceleration 1.6. Now how ridiculous is that? Dekho, what is, if I ask you what is the acceleration at time t equal to 15 seconds, it is minus 8 second, plus 1.6 second, and as it is occurring at the same instant, it can be any value between minus 8 to 1.6 seconds. Are you with me?
Yes, sir.
So at a given instant of time, how the hell body can have infinite accelerations? It is not physically possible. Do you agree with me?
Yes, sir.
Indicating the velocity time diagram which has been given to you is not correct. Are you with me?
Yes, sir.
Now, velocity time diagram correct नहीं है, ये हमें कैसे समझता है? Velocity time diagram incorrect है, ये हमें तब समझेगा when you see a kink. इस point को हम बोलते हैं kink. Are you with me?
Yes, sir.
What is a kink? Kink is a point at which, if you look at the function from left and right hand side, its tangent at that point will have different values of slope. Are you with me? तो ये continuous function तो है, लेकिन वहां पे slope of tangent from left hand side and right hand side is different. ऐसे वाले point को हम बोलेंगे kink. Are you with me?
Yes, sir.
At time t equal to 5 seconds, no doubt the nature of curve was varying from linear to parabolic, but it was not kink. Are you with me?
Yes, sir.
So whenever you see kinks in velocity time diagram, you have to understand that these diagrams are not physically consistent. ये diagrams हो नहीं सकते. But these are the idealized velocity time diagram. तो कोई तो एक problem होगा जिसमें ये idealized velocity time diagram लिया होगा, जिसमें the velocity must have changed from जिसमें acceleration must have changed from minus 8 to 1.6 seconds in very short duration of time. Are you with me?
Yes, sir.
बहुत शॉर्ट ड्यूरेशन में चेंज हुआ, इसलिए उसको आइडियलाइज कर दिया कि एक ही इंस्टेंट पे हो रहा है. आर यू विद मी?
Yes, sir.
But it is not physically possible. Can you give me an example where the acceleration changes abruptly in very short duration of time, which can be idealized as almost the same instant? आपने टू व्हीलर पे व्हीली तो किया होगा. आर यू विद मी?
Yes, sir.
So what we do there? Brake is fully applied, and then we raise accelerator to fullest possible extent, and we just leave brake abruptly. Then the velocity was zero, and velocity becomes something else in almost no time. Are you with me?
Yes, sir.
Also, acceleration was zero, and acceleration becomes something else almost in no time. So what do you experience there? You experience jerk. Do you agree with me?
Yes, sir.
हाँ, सो अगर हम एक डायग्राम और एक डिफरेंशिएशन और लेते हैं, if I differentiate acceleration with reference to time, I get a quantity called as jerk, which can be physically experienced. Are you with me?
Yes, sir.
You may not experience velocity physically. You can simply say that you are moving. You may not experience acceleration physically. You may simply say that you may simply experience that you are speeding up or slowing down. However, jerk is experienced by physically. Are you with me? If there is sudden change in acceleration, you will experience jerk. Are you with me?
Sir, this jerk is in line with the conservation of moment of inertia, right, sir?
No, we will come to that little later, not now.
Okay, sir.
So we will talk about that. And yes, we have terms of dA by dt in deriving that principle, but we will talk about that later. Are you with me?
Yes, sir.
Okay. So
Sir,
yeah, yes,
so
go
I
ahead.
had a doubt, sir.
Yeah.
So if we, for the particular solution, for the particular example that you gave, sir, of abruptly applying the brakes so that like the acceleration instantly changes to a different value, sir. If
Yes.
we, however, if we divide the time into smaller intervals, sir, the acceleration would be turn out to be linear, sir. It won't be
That,
a abrupt change, sir, if we increase the time interval.
that's
Or
what that's what precisely I'm trying to say. In this world, it is not possible to have, change the acceleration from zero to some other value instantaneously. हो ही नहीं सकता. Are you with
yes,
me? However, जिस टाइम इंटरवल में वो एक्सेलरेशन चेंज हुआ है, वो टाइम इंटरवल अगर बहुत छोटा है, then it is as if we can idealize it to occur instantaneously for all practical purposes of analysis of motion. Are you with me?
yes, sir.
And at that time, dA by dt jerk will be infinite. Are you with
Yes, sir.
me? So infinite jerk is not physically possible. However, if the acceleration changes abruptly in very small duration of time, we can idealize that as an instantaneous change in acceleration without much loss of other motion parameters. Are you with me?
Yes, sir.
Okay, so therefore we understand here that this velocity time diagram is idealized one, and we also make a note that sudden change in acceleration time diagram will manifest itself as a kink in velocity time diagram. Are you with me?
Yes, sir.
So sudden change in acceleration time diagram is manifested as kink in velocity time diagram. Sudden change in velocity time diagram manifests itself as a kink in position time diagram. Are you with me?
Yes, sir.
So ये हम remarks लिखने वाले हैं at the end. However, now let us talk about this zone 15 to 40 seconds. Now we have obtained one point there, 1.6, and what is dv by dt at time t equal to 40 seconds? It is 0. So therefore
Zero.
acceleration is here is 0, and we have 2 points. We can join these 2 points to form a line. Do you agree with me?
Yes, sir.
Okay, important observation. Slope of tangent drawn at time t equal to 15 seconds to this red color parabola is positive, and this slope goes on reducing. The line becomes flatter and flatter, and it becomes 0 here. So therefore, I should see acceleration to be maximum 1.6 at 15 seconds, and it should go on reducing but remain positive, and finally it will become 0 at 40 seconds. Are you with me?
Yes, sir.
Okay, so we have now drawn uh, acceleration time diagram, knowing the equations of velocity time diagram and knowing the basic concepts or graphical representation of differentiation. Are you with me?
Yes, sir.
Now we have to draw now position time diagram. So एक ही problem में I am going to do reverse operation and forward operation. Forward operation हो गया differentiation. Now to get ST diagram from velocity time diagram, I will have to do integration. Do you agree with me?
Yes, sir.
So that is reverse operation. Reverse operation means I now will be dealing with areas under velocity time diagram. Do you agree with me?
Yes, sir.
Now, this we are going to do this part in the next class, but let me quickly divide this into three areas. Area under velocity time diagram from 0 to 5 seconds, area under velocity time diagram from 5 to 15 seconds, and area under velocity time diagram from 15 to 40 seconds. तीन अलग अलग इक्वेशन है, तीन अलग अलग एरियाज होंगे. Do you agree with me?
Yes, sir.
That A1, I need not integrate. I can simply write it as area of triangle, half 10 into 5. Do you agree with me?
Yes, sir.
Now, how do I get A2? For A2, I will have to integrate this equation of parabola from limits 5 to 15 because integration gives you inscribed area. Do you agree with me?
Yes, sir.
So A2 is integration 5 to 15 A2 t square plus B2 t plus C2. Agreed?
Yes, sir.
And to get this area A3, what will I have to do? I will have to integrate this equation from 15 to 40 seconds. So integration 15 to 40 seconds, A3 t square plus A3 t plus C3 dt. This is area A3. Do you agree with me?
Yes, sir.
So first of all, in next class, we are going to calculate this, and then we are going to draw ST diagrams. But before we stop today, देखो, velocity time diagram is linear here. Its integration must be parabolic. Do you agree?
Yes, sir.
So therefore, ST diagram is parabolic in 0 to 5. As the velocity time diagram is parabolic in 5 to 15 seconds, ST diagram must be cubic.
Yes,
Are
sir.
you with me? Similarly, from 15 to 40 seconds, ST diagram is going to be cubic. Happy?
Yes, sir.
So with this, we are going to close for today. Once we solve this problem, we are going to make almost 7 to 8 remarks. And those remarks are the most important points that you must understand in order to solve such kind of problems. So with this, let us stop here today. Have a good day. If you
Thank
have
you.
any doubt, you can ask me now, or you can put, or there are no doubts, you can leave the class and put your attendance in our link.
Thank you, sir.
Thank you,
Yes.
sir.